Hello, AP Stats. This is the homework I assigned for you guys to do last Friday from question 11 through question 30. I know that I asked you to skip several questions, but with the new information that I've taught you with the T distributions, I believe we do have sufficient information to be able to solve most of these, if not all of them. And so I'm going to go start with just question 11 right away. And when I first tried this, guys, for question 11 was one of those questions where I just could not get the correct answer here. So if you read this carefully, it's chapter 4 material. It's talking about a repeated reading and multiple quizzing, so those two different methods. With the cooperation of the teacher of a 6th grade course, she compiles a list of 36 topics. Using a computer, she randomly assigns 10-digit decimal to each topic and sorts the topics according to the random decimals. The students in the class then learn the first 18 topics of the resulting list using repeated reading and the other 18 topics using multiple quizzing. On the final exam, the performance of the students, they are measured, and then of the performance of the topics taught by multiple quizzing versus the repeated reading. So which of the following is true? First, let's get rid of the fact that this is an observational study. Clearly, you're imposing treatments to the subjects, which is the students here. So this is an experiment. This is an experiment in which students are randomly assigned to a treatment. That is not true because it doesn't say that. What's being randomized here are the two treatments that's provided, which is the repeated reading and the students and the multiple quizzing. Sorry. Okay, so between these two, how are they randomized? Well, they're randomized by using 10-digit decimal, and they're all the order of the source of the topic according to random decimal. So the order in which that they're being taught this is also going to be randomized here. I said that this is an experiment in which two sets of topics form blocks according to learning approach. So I think the two sets of topics, maybe this was the issue. I don't know what made me say D, but this D answer choice, if you take a look, two sets of topics form blocks. So that is one measurement of per singular unit of subject. A block is imposing a treatment to a subject in which that in that category area, one specific result will come from. I don't quite remember what the blocks were at this stage, but we have 36 different sets of topics, and if you're setting each of those to be blocks where one of them is going to be the repeated reading and the multiple quizzing, and we compare the student's result, then it should be fine. But we have two separate independent samples. We have 18 separately, and then they're getting those treatments there. So I believe the best answer here is E. This is an experiment, definitely an experiment with everything just being completely randomized for this. It's not two sets of topics form blocks. This is the only issue that I saw. If the two blocks were the learning approaches, then it would have been a little bit of a better statement. Okay. So 11, again, chapter 4 stuff is not my strong suit, but at the moment, that's the best explanation I can give you. I will have to go over the blocks one more time before you guys take the exam. So let's just put it E down for now. Number 12 is easy though. If the people who grade the final exam does not know, any single time when you're not told that some information, it's going to be called blinding. Placebo, randomization, replication, direct control, none of that stuff has the same definition as blinding. You're blinding the subject, blinding the experimenter is called double blind. If you're blinding just the subjects, that's just blind test. Always just make sure you know the vocabulary for that. Which of the following are true? Now, we haven't actually talked about a chi-square test yet. For this, I believe the correct answer here, they said it was B, if I'm not mistaken. Let's see. Yep, 13 is B. So 13, some binomial distributions are negatively skewed. Binomial distributions, as you remember, are the distributions where you have 20%, 80%, you have a chance of success or failure. If your chance of success is actually a lot, let's say less versus chance of failure being high, then if you were to actually take a distribution, more chances in which you have less occurrence of success will happen because there's just simply more chance of failures. So let's say you're measuring from 0 to 10, 10 being the number of outcomes that's being success. more outcomes will end up being failures and only few will be success because you have more chance of actually getting failure. So it can definitely be negatively skewed or positively skewed in this case. But if I change the order of these two, you can have skewed distributions for binomial. T distribution, chi-squared, and z distributions, they're all going to be just simply a normal distribution. This is why you can calculate the z-score, z values, and find from the normal distribution how much percentage will be. So always understand that the T distributions and the chi-squared, they will be normal regardless. Okay, number 14. This right here, using a sample size of 30, that ensures the normality. So distribution of all possible is normal. So we are looking for A, B, and C. D and E has absolutely nothing to do with this. So distribution of the amount saved for all students at the university is approximately normal. This is talking about the population. We're not talking about the population. The reason why we want to make the sample size to be as big as possible is for your sample, but not just one of the samples here, but for all possible samples to be normally distributed. So the correct answer here would be C. B and C are kind of saying the same thing, but C is the better answer because we're talking about all possible sample mean to be normally distributed. 15, I hope you guys will remember what R squared was back from chapter 3. 68% of the variation in the response variable is directly impacted or not directly impacted. It can be measured by the least squares regression line that is due to the explanatory variable. That is the template that I asked you guys to remember for your FRQs. So the Y, which is the amount of love of learning. So that will be the 68% of the variation of the love of learning, which is A. So always the 68% of the variation of the response variable is accounted by the explanatory variable in the least squares regression line. That's what you want to say for questions like these. Number 16, we have a significance of 5%, and we have two samples here. And we want to say a hypothesis test was conducted to see if the female employees is greater. So let's pull out a calculator and let's go to stat. Let's go to two proportion Z test actually, because we're talking about proportions here. The first one is 18 males had 200 out of 212 had the emoticon, and 26 out of 186. And now you got to be careful. P1 being male, P2 being male, P2 being female. You want to conduct a study where female is greater than. So you want to have female P2 to be greater. And then we are just simply going to calculate. And we have our P value of 0.04. At the significance of 5% level, which is the alpha, we know that P is less than. P is less than 0.05. So it's going to be C and D. If we have P is less than alpha, then we reject the null. So there is a convincing evidence that the alternative hypothesis is true. So there's convincing evidence of a greater proportion of female messages, so which is C. That is our alternative hypothesis. We want to say that there's enough evidence or convincing evidence to support that claim. All right, 17. We've done this before. Whenever you're trying to solve for the sample size, you want to make the sample proportion to be as large as possible. So produce the greatest margin of error. Remember, the margin of error is accounted for P hat 1 minus P over N. In order to make this numerator value as greatest as possible, we need to put 0.5. All of the other ones will not give you the largest numerator value, so it's only going to be B. All right, so 18% is your chance of success, or 0.18. What is a probability that less than 3 of the next 8 vehicles? You need to understand that this is going to be binomial. How do I know that? We have a chance of success. It tells you that. And also it tells you how many fixed trials there will be. If there's no fixed trials, we call it a geometric, where you keep on doing until you have one successful try. So 3 out of 8, 8, 3, and I believe it's probability of success of 3 times probability of failure of I think it's 5. But not only that, if it says less than 3, you actually have to consider 2, 1, or 0 being your total possible outcomes. Less than 3 means 3 is actually not part of your probability that you're looking for. Ignore this formula. I just kind of gave you this as a sort of like for you guys to know that this thing that we did a long time ago, NCR, is the binomial formula you have to use. But better yet, it's a calculator problem, if anything. And we're simply going to go to second VARs. And hopefully you guys remember the binomial CDF because we're combining 0, 1, 2 together. Trials, we have 8. It's 0.18, the success. We want to have 2. We want to go up until 2. Okay, CDF means it's going to combine everything from 0 onwards. So you stop at 2 and paste. You have a really nice number of D, 0.839. All right, number 19. This is actually going to be quite easy. What is the probability that the list length of the call was 5 minutes or less, given that it was not 1 minute? So 1 minute is not part of this. So let's count how many there are. Okay, so I literally have to count those. 5, 4, 1, 1, 2, 1, 2, 1. That's 9. This entire thing here would be 8. So that's a total of 17 calls. What is the probability the listed length of the call was 5 minutes or less? So 5 minutes or less are these 4 things. 5, 4 plus 1 plus 1. That's 11. So 11 out of 17. Let's type that into our calculator. 0.647 is the correct answer, which is C. All right, number 20. A particular state has recently introduced the law includes possible prison sentences. 82 people responded to the survey and their answer. So they sent a magazine questionnaire to random sample of 200. 82 people just decided to respond to the survey. It didn't really say they support it or not. And generally speaking, showed approval for the law. This result was used in the magazine to describe the opinions of adults in the state as a whole. Why is there a potential bias? Well, this is what I would like to call non-response bias. You have more than half of the questionnaires not being returned back to you with the answers. 200 is a good sample size. That's not what you want to say a too small of a sample size. People vary a lot in their attitude to distracted driving. I don't really think that's the right answer, or even in real life. Adults who respond to a survey like this might generally have opinions that differ from those adults who do not respond. That is true. If you're actually very active in, having this law passed, you'll be more vocal about it, and then you actually respond to a survey, rather versus this 118 people who just simply do not care. So they actually have opinions, and that's why generally they showed approval for the law. The sample could by chance have included many people who feel strongly about distracted driving. D is also a good way of saying it, but then C is a better choice than D. It is possible that actually adults who live in the state generally disapprove of the news law. Again, that's too vague, and the best answer amongst C, D, and E is C for this one. All right, so we haven't, there was another one. Yeah, so here we have 5 cumulative relative frequency graphs. We're talking about the largest variability. Variability means how much does the data differ? At the 70th percentile and the 30th percentile, like where do you kind of go? Well, this is 0 to 1. You want to look from here as 100% of the data, and this is 0% of the data. So maybe 30% is somewhere here, and 70% is somewhere here. And if you keep on doing the same thing for all of these values, roughly give or take. Now notice how the data points from these 2 dots in a horizontal distance that measures your variability. Now you can see how C has the smallest variability out of the 5 choices, and I think it's clear as day that A is the correct answer. The variability in terms of data is large at the 30th and the 70th percentile. So that's, it's going up by tens, like 10, 20, 30, 40, 50, 60, 70, all the way to 100% at the top. And the variability is how long the horizontal distance from those 2 dots are going to be. 22. This is simply understanding the formula in one of your formula sheet. Always your numerator is going to have x1, x2 bar when you're comparing the 2 sample means together. And do not forget that the denominator always must contain some sort of a square root whenever you're deciding to figure out the standardized test statistic for Z and things like that. You always need to have a square root of something when you're combining variances together. For variances or standard deviation of the sample size, it was this. To find the variance, you square the standard deviation, which gives you this. Then you can combine the 2 variances together, and then you have to square root the whole thing. So the correct answer here is going to be C. This is, well, A is not, it doesn't have a square in it, so that's the mistake. This one is like combining the two sample standard deviations together and finding the average of the two. You're not going to do that for standard deviations. Remember, standard deviations, you always cannot find averages. Rather, you're combining the variances to whenever you have two sample means of two independent samples. So C is just the correct answer for this one, 22. 23, we have 38% in support. So what does this p-value mean? Guys, the p-value always represents when you assume null to be true, the chance of you getting that up to the value of the p-value, like the whatever the sample that you got. So the first thing I want to say is let's eliminate A and B, because when you take a look at C, D, and E, given the support for the party has not changed, they give you that because they need to assume that the null hypothesis is true. Assuming that the null hypothesis is true, what does this p-value represent? That's the probability in which how extreme of a sample data. In terms of this, they say it was a Z statistic. The proportion of the Z statistic that you're going to get, but the way that you phrase it is the key. The probability of getting the Z statistic calculated, the probability of getting Z statistic at least as far above 0. This is not the right choice here because it can actually go below 0. So the probability of getting a Z statistic at least as far from 0, E is a better choice than C. Yes, it's calculated in the study, but we're also, the way that we kind of better phrase it is how far of an extreme of the values that can we get from the mean. So the better way to phrase number 23's answer is E. And checking the answer choice, yep, that should be E from here. 24, we have 50 as your sample. KB, the probability, the proportion of days in which Monty gets the cheese is less than 0.53. Once again, this is a binomial. How do I know that? You have two doors. Each of the doors is an equal chance of being open, so it's 0.5 for the probability. We're going to do a binomial PDF, binomial CDF. But if we're talking about the proportion of the days in which Monty gets the cheese is less than 0.53, you need to first account for the fact that the sample here is 50 days. So if you actually go to your calculator here, it's going to ask you for 4 separate things. So second vars and binomial CDF. I'm sorry, 3 things. The number of trials is 50. Chance of you getting actually the cheese is 0.5. But for X value, you can't put 0.53. Remember, it's 53% of the 50 days that you're expected to get the cheese. So if you actually take in 0.53 times 50, you actually get 26.5. I'll show you that for you real quick. So 50 times 0.53, 26.5. So you want to say it's less than 26.5, which means you can start from the 26th day. So let me go to binomial CDF. Trials 50, chance of success, and this will be 26. I'm sorry, not 0.18. This is 0.50. So 26 days or less. What's your chance of actually getting that? It's about 66.4%. So if you were to draw a distribution curve for the binomial, you're basically looking at where 0.53 is. So this is like 100% of the data. 0.53 is here. 0.53 of the 50 days, which is 26.5 days. Anything that is less than 26.5 up to that point, what's the chance of that happening? Use the CDF and get the answer right away. How do I know it's binomial again? I have a chance of success and chance of failure. It gives you that. 25. This is something that we can do now because now I've talked to you about T interval. It's a 90% confidence, which means if I were to draw a T distribution, where this is 90% in the middle, that leaves us with 5% on either end. This means I go from left about 95% in total. So you're simply going to go have to go to second vars inverse T, area is 0.95, degrees of freedom. It seems like they selected 20 homes, so we're going to put 19 for our degrees of freedom. So 1.729 is the correct answer. All right, 26. For 26, we have a A set of volunteers was gathered for the study. This is just a really slap in the face question because when you spend all this time like reading over, I first thought that it was C, a paired, oh, I'm sorry, not paired, because paired means one, it's not going to be independent samples from one another. One thing like takes both fork and maybe fork along with other utensils, a knife and a fork. I thought it was going to be a 2-sample t-test. We have a heads, the volunteer was asked to eat a meal with using a knife and a fork. That's your one independent sample versus another volunteer was asked to eat a meal using a fork only. So you have 2 separate independent samples. So therefore you take 2-sample t-test. But the problem here was that these were volunteers and they are maybe speedy eaters who likes to use knives versus forks or whatever. So no hypothesis test is suitable since the study did not use a random sample of people. They say that's the correct answer, but in all honesty, if I was taking this test, I would not have gotten this right. I would have just said it was 2-sample t-test and moved on. But this obviously, I overlooked the fact that these were volunteers. So whenever you see these, this word, be unaware, and rarely you want to choose the answer choice E, but that's how it is for this question. It is what it is. 27, we have EVA, z-score for the EVA time, negative 1.37 and 1.09. It's good if you know this. The z-score is always the value minus the mean over the standard deviation. They were generous enough to share with me the standard deviation. They have x1 minus the mean of x and x2 minus the mean of x because we have 2 separate locations for the EVA. Now, one of the z-score is negative 1.37 and the other one is 1.09. Let's do some simple math and move this to the other side by multiplying those 2 values there. So what that means is negative 1.37 minus 7.94. So the first data point subtracted from the mean, that differs by about negative 9.31. And 1.09 times 7.94, that's about 8.6546 x2 minus x bar. Now, they're asking you to find out what is the difference in hours of these two. Well, why don't you just subtract the top and bottom as if it was systems of equations? These two will cancel out because it's negative and negative x, and double negatives makes it a positive. That's negative 9.31 minus 8.546. So I am just going to take this minus this answer. So what I get is x1 minus x2 equals 17.9646. Technically, it should be a negative number, but they ask you for the difference here. I might have made one single mistake. Yes, so I did not multiply this value. So let's take this number and multiply this. So this is supposed to be actually negative 10.878. My apologies there. And then when you subtract this number from it, you get negative 19.5324. So that means that the answer is D. I know it says positive version of it, but it's the difference. So if you swap these two around, x2 minus x1, therefore should be positive 19.5324. Okay, so that's the positive difference. Next, we have the car suffered from scratch 0.2, charge for return the car late is 0.6. So these two events are independent. What is the probability the tourist will be charged for exactly one of these two things? Draw a tree diagram, please. The chance that you actually get scratched, let's say, or not scratched, CS complement will be 0.8. Now you get scratched and you get car late. So I'll call late here. That's 0.6 this way. And not late is 0.4. Late is 0.6 and not late is 0.4 once again. Now, if I want to have at least one of these things, it means that I want to find out that this, you scratched, not turned in late. And it's not scratched, but it's turned in late. Because these two will be having exactly one of these two things happening. So if it's independent, I can simply just multiply those two probabilities and just add them up. 0.56 would be the correct answer for 28. And for 28, it is indeed B. Number 29. 29 is also one of those things that I just simply was not able to get it. The correct answer here, they said, was E. I tend to disagree. N is a sample size. And remember, whenever you're increasing the sample size, your standard deviation has to decrease. That's how I always thought of. And when the sample standard deviation or the sample standard variances, I'm not standard variances, the sample variances decrease. Consequently, what that will have for you in terms of your sample mean standard deviation of the sample distributions of the sample mean, I'm sorry, that should also decrease because it's getting narrower and your standard deviation should always be getting smaller there. So I said that it was D. I would honestly just put D and move on. I'm not sure why they say that it was S squared neither tends to increase nor tends to decrease. Yeah, so I have no clue as to why that would be. I thought it was going to be decreasing. So we're going to put a little star next to 29 and assume that we're just going to take L for that question. And we're going to move on. Number 30. 30 should be doable. It's an empirical rule formula, chapter 2. So we are looking for anything that is less than 12.0 and greater than 12.5. These are the ones that actually is not going to be sufficient. So those are the ones that you kind of want to say, okay, those are not going to work out. And the standard deviation is 0.2 with the mean of 12.3, which means I can take this 12.3. If I move one standard deviation, voila, I get 12.5. So this probability of Z is less than 1. That counts for all of the probabilities there. But if I want to take into account of how much probability this is, well, that is 1 minus the probability of Z score less than 1. So that right-hand side probability is represented with 1 minus PZ is less than 1. Now, how do we go from 12.3 with 12.0? How many standard deviations did you move left by? Well, the standard deviation is 0.2. And I need to go 0.1 more. So that's about negative 1.5 standard deviations to the left. So that is probability of Z is less than negative 1.5. And that's quite easy because remember, the Z score probability, they always calculates it from the left. So probability of Z less than negative 1.5 is simply just going to be that. So when you add these two together combined, that's going to be the answer. It seems to me that I have the last answer here, which is E. That part is represented on the right-hand side. That part represents the probability on the left-hand side. And so the correct answer is E. Okay, so I hope this helps in understanding the middle of the 20 multiple choice questions. Like I said, some of these are really not bad and some of the chapter 4 stuff are just still getting to me still. But hopefully as the time goes by, we can kind of really just knock it down and get a better score than, what we had originally had gotten before. Our average, it was like 5s, 6s, and 7s. I really hope that we can increase the score average up. And yeah, that should be it for this video. Thank you so much. I'll see you next time.